All right, let's go over this one. This is from, doesn't say it, 8.3 homework probably. Use the one mean t-interval procedure with the sample mean, sample size, and sample standard deviation and confidence level given to find the confidence interval for the mean of the population from which the sample was drawn. So A, let's find the confidence interval of what? 99% confidence interval given x bar is 18, n is 25, and s is 4. Any of the confidence interval, you can find it on StatCrunch, or you can do it on formula, using the formula that's on the Google slide. But I'm going to go ahead and just do it the easy way. I'll just go ahead and use my technology to find it. So the important thing is you need to know which buttons to press, where to go. Alright, it's not logged in, so let me try again. Okay, so we're trying to create a confidence interval for population mean, right? So go to stat and t-stat. Why t-stat instead of z-stat or anything else? Well, because we don't have the population standard deviation. What we were given is the sample standard deviation. In that case, you have to use t-distribution. So go to t-stat. We have one sample and we have data. We have summary, right? They gave you what is a sample mean, what is a sample standard deviation, what's the sample size. So that's where we go. Stat, t-stat, one sample with summary. And let me see what the inputs were. So let me try to get this tab out so that I can open the question that I was working on. All right, so I'm working with the sample mean of 18, standard deviation of 4, sample standard deviation, the little s, and the sample size of 25. And they want the confidence level to be 99%. So click on the confidence interval and change that to 99% and compute. There we go, we have it. So the 99% confidence interval is from 15.7. All right, they want you to round it to the nearest, round to 3 decimal places. So that's going to be my first number for the lower limit. And what's my other number? The upper limit. So what we just got, I'm going to have to round that last number up to 8. What we just got is that the confidence level, we're 99% confident that we will be able to capture the true population mean in this interval, whatever they are talking about. So they're talking about mean of something, average of something, but we know that using this, numbers that are given, we're 99% confident that the true population mean will be in between these two numbers. So they want you to find the margin of error by taking the half the length of the confidence interval. So really, they told you how to do it. So take your little calculator and figure out how long this confidence level interval is. 20.238 minus 15.762. And that's the entire interval. But remember, margin of error is something that you add to the midpoint, that middle point called the point estimate, to go to the upper bound and go to the lower bound. So you need to divide this by 2. So the margin of error is simply 2.238. 2.238. All right, let's take a look at the last part. Margin of error found by using the formula. Now they want you to use the formula this time. So we will have to actually, it should be almost the same thing, but maybe a little different. So what we are going to do is use this formula they gave us. Let me open up a file, just a notepad, so that I can type up the formula. Now, if you take a look, the margin of error, ME, they gave it to you as what? T, and the notation they have is T's of what? Alpha divided by, where is my alpha symbol? 2. And then you're going to multiply this by the quotient. You put the standard deviation of sample standard deviation on top, and you put the sample size square rooted in the bottom. So I guess the easy part is that quotient. You know exactly what that quotient part is. S is given to you as what? 4. and the sample size is given to you as 25. So that part is easy, but then the question is remember how to find this number, the t value. Let's go ahead and find that number so that we can just multiply that to 4 over 5 here. So what's the alpha level? For our confidence interval, the alpha level is 99%, right? So what you want to do is, okay, 99% divided by 2. But we should probably say 0.01. Because remember, 99%, having 99% in the middle is having 1% to the right and left of it. So if you do that, what we are really looking for is a t-value that has how much cumulative to the left? 0.005, right? Because half of 0.1 is 0.005. So let's go ahead and find that number on this table. I mean, they gave you a table. We used StatCrunch to find it because that's going to be a little more accurate. But yeah, I think I'm going to, since they gave me these tables, I'll go ahead and use it. So 0.005 to the right or to the left. So it doesn't matter. 0.005. I'm going to find the value that has, by the way, what's the degrees of freedom? When n is 25, degrees of freedom is 1 less than 25. So I need 24 degrees of freedom. So not on that second part, but I need it over here. So 24 is listed right here. And I need 0.005. So the last column, right? It's so hard to see. T of 0.005, that's what we want, with degrees of freedom 24. So the t-value that we want to use is 2.797. Now that's not how I did it in class or in my lesson videos. I just use t calculator. I think I'm going to do that too and show you how close this is. 2.797 is from this table. I'll write that down. 2.797. Oh gosh, I forgot. I'm sorry. 2.797 was it? Yeah. But I never really used this table just because I had something better. So on StatCrunch, what I did was I actually used the T calculator. Go to Stat, T calculator, and then we typed degrees of freedom. Yeah, you have to know that as the sample size minus 25. So we got that, 24. And we can do the same one. We can do greater than 0. 0.0. I forgot. Hold on a second. Let me go back. We're looking for the t-value, right? So 0.005. So we want a t-value that has 0.005 to the right of it or to the left of it. If you do to the left of it, you're just going to get a negative one. But if you go ahead and calculate it now, that looks the same. 2.797 is rounded up to the 3 decimal places. So that's how I showed in my videos because that's going to give us the more accurate answers. And this calculator does degrees of freedom of any number, like 1 through a big number. But if you take a look, the tables they give you, degrees of freedom goes from 1 through 10, 11, but at a certain point, they stop giving you accurate numbers. Like after, like, let's say, like, okay, after 90, like 75-ish, it goes up by 5, right? So what if your sample size is 89? Then I guess you just gotta go and use the closest one. But T calculator will give you the most accurate test statistics t-value. But either way, we kind of round this one. This one was designed so that we were able to get the very accurate test statistic value by looking at the table. So anyway, so we know that t number is this 2.797. So we're going to multiply this by the fraction, and we can simplify that fraction to be what? 4 over 5. So all you need to do is just simply multiply 2.797, and I'll just do this on my cell phone calculator because this one isn't too much. So what's that going to be? So I'll do 2.797 times 4, and then divide that by 5. You should get 2.32376. And I can't remember the rounding rule. Did they say round to the near 3 decimal places? Let's see. is 3 decimal places as needed. So I'll just round that up to 2.238. Now, notice it's the exact same thing as what we got from taking half of the confidence interval and dividing it. There could be a little, like, they may be slightly off because of the rounding or different things, but well, this problem, they happen to be exactly the same, and that's what they kind of want you to see. But it's much easier to just find the confidence. But that's why technology is so useful. We can find the confidence interval and actually get the margin of error by just figuring out how long this confidence interval is and just dividing it by 2. But if you don't have that tool, you have to use find every pieces to plug into the formula. But that's it for 8.3.123. And that was on confidence interval for sample a population mean.